Hello, and welcome to this video about tetrahedral numbers. Tetrahedral numbers are numbers that make the shape of a tetrahedron when gathered together. The xth tetrahedral number is given by this equation, being the sum of all the triangular numbers. The TR function is the triangular number function, and the TD function is the tetrahedral function. This function is also equal to this combinatorics function. When this combinatorics function is expanded out, we get this formula for the xth tetrahedral number. Expanding and then simplifying this expression gives us this formula, which is the formula that we will derive in this video. This is also a good iterative formula for the xth tetrahedral number. And this is the formula for the xth triangular number that we'll need for this derivation. Now, to prove that equation 2 is correct, we'll do this by deriving it. We'll make the assumption that the tetrahedral number can be expressed as this cubic polynomial. So then we'll have to find all of the coefficients of this polynomial. We'll substitute x plus 1 in for x for this polynomial, giving us the x plus 1th tetrahedral number. This is a legitimate step in this proof. Then we'll expand all of the power terms of this expression to give us this equation. I'll just write it out again here at the top. Now we'll expand all of the brackets. Then we'll gather like terms together, all of the constant terms and x terms and x squared terms, and place them in brackets. We'll make a similar substitution into the iterative equation to give us this expression. And we'll substitute this formula for the x plus 1th triangular number into this equation to give us this expression. And I'll just rewrite it at the top of the screen. We'll substitute the polynomial equation in for the xth tetrahedral number to give us this expression. We're also expanding the term on the far right of this equation. We'll begin to simplify this expression. Then we'll gather all like terms in terms of x together. We'll then place brackets around the like terms to give us this equation. So now we have two different equations for the x plus 1th tetrahedral number that we can equate together and use this new equation to find all of the coefficients of the polynomial that we're trying to find. I'll just rewrite this equation at the top of the screen. Now we can separate out all of the terms in this equation so that we can get 3 of the coefficients of the polynomial. We'll start off by separating out all of the constant terms to get this equation. Simplifying this equation gives us this equation. We can separate out all of the x terms to give us this equation. Then we can divide both sides by x. And after simplification we get this equation. We can then separate out all of the x squared terms. Then we can divide both sides by x squared. We can simplify this equation to give us this equation, which looks like it will solve one of the coefficients. And so it does. We have one of the coefficients of this polynomial that we're trying to find. Separating out all of the x cubed terms gives us this equation, which doesn't tell us anything, and that can be ignored. So now to find another 2 of the coefficients using these 3 equations. Making this substitution gives us this expression. Then we'll simplify it a bit, and then we'll have this expression, which should simplify to give us the coefficient a2, which it does. So we've found the coefficient a2. We can then make this substitution, which will give us the solution to this coefficient. We have 3 of the 4 coefficients. We still have to find this remaining coefficient a0. We'll use the fact that the first tetrahedral number is 1. We can find it using the series equation 1. We can then substitute all of the known coefficients and x is equal to 1 into the polynomial equation, and then start to simplify it. So then we can get the value of the constant coefficient a0. Now we have all of the coefficients. We can substitute all of these coefficients into the polynomial. We can eliminate the 0, and we'll have this equation for the xth tetrahedral number. So we've derived this equation, and thus proven that it is true. We can also prove that this equation is correct using mathematical induction. The first step is to prove it true for the first number, which is 1 in this case. And then we can very quickly show that this formula is correct for x is equal to 1. Now we have to prove it true for the next number, if it is true for the present number, by assuming it is true for x and proving it true for x plus 1. We'll start off with this equation, which gives us the next tetrahedral number in terms of the previous tetrahedral number. We can then substitute all of the known formulas in. Then we'll expand out the x plus 1 squared term and simplify the polynomial on the right-hand side. I'll just rewrite it out again at the top of the screen. We'll give these fractions the same denominator. Then we'll make it into one fraction. Then we'll simplify the numerator. Then we'll unsimplify it, getting it ready for the final step. We'll then factorize these parts of the numerator. I'll just rewrite it up here. Now I'll get all of these bracketed terms into a power of x plus 1 term. You can see now that this is the formula for the x plus 1th tetrahedral number. So now step 2 is complete. In step 3, we combine steps 1 and 2 to prove it true for all integers greater than or equal to 1. So this proves the tetrahedral number formula by induction. So I hope that you have enjoyed watching this video and have felt that you have learnt a lot from it. Please click like and subscribe, and leave all your ideas and advice in the comments. Thanks for watching.